Okay, so today we are going to do 10.5, which is surface area and volume. So volume is three-dimensional and it refers to the amount of space that is occupied by an object. It's determined by the number of cubic units. So area was square units, and you multiplied two things. Volume is cubic units, and you're multiplying three things. So you're for something that's like an actual cube, you're gonna do length times width times height rather than just length times width. In general, the volume of a rectangular solid is the product of all the lengths of its sides, the length of all its sides. So here are two formulas. So volumes of box line shapes. So these are things that could be boxes. You have a rectangular solid, which is going to be length times width times height. And you have a cubic solid, which is going to be side times side times side, which actually gets you side cubed. Everything you're going to do, if you look, is now in cubic units, not just squared. So now since we're multiplying three things, you are in cubes and not squares. So these are obviously different numbers. So to find the volume, you're going to do 2 times 6 times 4. I know that 2 times 6 is 12, and 12 times 4 is going to be 48, and this is going to be meters cubed. For B, these are all the same. So this is obviously then going to be a square, a square cube. So you are going to then take volume is equal to 4 cubed. 4 times 4 is 16, and 16 times 4 is 64, and this is centimeters cubed. So those ones are kind of easy. They're very similar to area. A polyhedron is a solid figure bounded by polygons called faces. So we're going to talk about pyramids next. A pyramid is a polyhedron because you have triangles in a rectangle or a square, so it just depends. A rectangular solid is bounded by 6 rectangles. So if we go back up to A here, if you look, it's bounded by 6 rectangles. You have the front and the back, the top and the bottom, so that's 4, the left and the right. So you have 4 rectangles that make that up. That's what that is talking about. So a pyramid is a polyhedron whose base is a polygon and whose sides are triangles. To find the volume of a pyramid, you're going to take 1/3 base times height. The height is going to be this dotted line in the middle. It forms a right angle with the base. It's a big B, not a little b, because that's the area of the base. So you have to find the area of the base and then multiply that by the height and then 1/3. So let's try this out. So our base is going to be a rectangle. So to find the area of the base, you're going to do 5 times 7. So big B is 35. And this is that's going to be yards squared. To find the volume, you're going to take 1/3 of your big B, which was 35, times your height, which is 15. I know that 15 divided by 3 is 5. 5 times 35, 5 times. So it's going to be 175 yards cubed. Since this one was yards squared and this one was yards, you have a 2 and a 2 and a 1, technically, which give you a 3. So do the same thing for this one. So you're going to have a big B. We got to find that first. You're going to do 4 times 7. So your big B is going to be 28. And then you're going to do volume is equal to 1/3 of 28 times 6. 6 divided by 3 is 2. 28 times 2 is 56 inches cubed. Again, the big B is inches squared, and the 6 is inches, so that's where you get the inches cubed. Not every three-dimensional figure is a polyhedron. So anytime you have a cylinder, it's not a polyhedron because you have two circles, but it's not encased by circles. You have two circles, and then you have like a rim around the outside. That rim is not a shape that we know, so that's not considered a polyhedron. So anytime you have a right circular cylinder, this is the formula you are going to use. So R is obviously radius, and H is obviously height. So you're going to do volume is equal to pi times the radius squared times the height. So sometimes they'll give you the diameter. Remember, the diameter is equal to 2 times the radius. So if they give you the diameter, divide it by 2 to get the radius. And they do give us that. So volume is equal to pi r squared h. Let me make sure that's right. Yep. So 20 yards is the whole diameter. So really, half of 20 is 10. So volume is going to be equal to 10 squared times 9 times pi. Volume then, 10 times 10 is 100 times 9 times pi. This is going to be then 900 pi. I'm going to leave it in terms of pi for the sake of this. Don't forget your yards cubed. Add that in there. You don't have to leave it in terms of pi. You can multiply that by 3.14 to get an exact answer. B, they also give you a diameter. So if the whole diameter is 24, your radius is 12. So you're going to do V is equal to 12 squared times 21 times pi. So this is going to be 144 times 21 times pi. So 144 times 21 is going to be a volume of 3,024 pi, I didn't multiply by pi, inches cubed. So obviously if you multiply by pi, that number will be bigger and an exact answer. So you can have a right circular cone. So instead of a cylinder, you have a cone. The volume of a cone is going to be here. It's the same exact thing as we had before, but they put this 1/3 out front. The reason is because if you could finish this and make it a cylinder again, but you took 2/3 of it away. So that's the reasoning there. You took 2/3 of this away, so that's why you take the 2/3. Because if you added that, like I said, you would be back to where you started. So you really have a third of what you had before. So we have volume is equal to 1/3 pi r squared h. So in this case, they do give you the radius. So we're going to use volume is equal to 1/3. I like to put pi last. I don't know why. The formulas always put it first. 7 squared times 10 pi. So this is actually going to be 1/3 of 49 times 10 pi. This is going to be 490 divided by 3. So I got a volume equal to 163.3 pi meters cubed. Again, you can multiply by pi if you'd like. That's just more work. On the homework, if it says leave in terms of pi, you would leave it like I left it. If it says round to the nearest tenth, you would then multiply pi in there. This one, they gave you the diameter. So this radius would be 3. So your volume is going to be equal to 1/3, 3 squared times 5 pi. So this is actually going to be 1/3 of 9 times 5 pi. That's going to get us to 45 divided by 3, which is 15. So this is going to be 15 pi, and this is yards cubed. Again, you can multiply by pi. I'm not going to, but if it says round, you need to. Sphere. A sphere is if you take a circle and you would spin it, you would end up making a sphere. So a sphere is a set of all points in a space equally distant from a given point, its center. So that little circle in the middle, that sphere example, that is the center. Any line segments from the center to a point is the radius. So you could draw anything. These would all be radii. That's what that's saying. So for the volume of a sphere, you're going to take 4/3 pi r cubed. So this time we're cubing r, multiplying by 4/3 pi. So volume is equal to 4/3 pi r cubed. So we have 6. Volume is equal to 4/3 6 cubed times pi. So 6 cubed is going to be 216. 216 times 4/3 is going to be 288 pi meters cubed. So a little trick here, those of you who maybe don't have a calculator or you don't have a fraction button, when you're multiplying by 4/3, so when I did 6 cubed, I got 216. If you're trying to do this part next, what you do is you multiply the top by 4 and then divide everything by 3. That's how I got 288. I multiplied that by 4 and then divided everything by 3. So if you don't have a calculator that you can do a fraction with, take whatever you get, multiply it by 4, and then divide it by 3. So we'll do the same thing here. This time they give us the diameter, so the radius is 9. So you're going to have V is equal to 4/3. This is going to be 9 cubed pi. So 9 cubed is 729. So I'm going to do 4 times 729 divided by 3. So times 4 divided by 3. I get the volume is equal to 972 pi. This is going to be centimeters cubed. So that's my example on how you would do that if you did not have a calculator. The last thing we're going to do, so we have composite figures with this, just like you had with area. So that's taking 2 3-dimensional shapes and putting on top of each other. This essentially is an ice cream cone. So it is officially ice cream season. So here, what we have is we have here a right circular cone. And here we have a sphere. But we have half a sphere. So we have the whole right circular cone and half a sphere. So the volume, I'm going to do the cone first. So volume for a cone, let's go back up, because remember, you can use your notes. Volume for a cone is going to be 1/3 pi r squared. So volume equals 1/3 pi r squared. So I'm going to do that one first, and then I'm going to do the sphere, which was 4/3 pi r cubed. So for the cone, what we're going to do is, if this whole thing is 12, that means this is going to be 6. So you're going to have 1/3 I'm missing the H here. That needs an H. My bad. 1/3 6 squared times 15 times pi. So I'm going to type that in my calculator. I'm going to leave pi in there. I'm not going to multiply it. So 6 squared is going to be 36. 36 times 15 is 540. 540 divided by 3 is going to give me 180 pi. So the volume of this cone right here in terms of pi is 180. I'm going to do the sphere. So for the sphere, I'm going to do 4/3 6 cubed pi. I think I already did that. I did. So I did that right here in the first example, and I got 288 pi. So this I got 288 pi. So the issue here, though, is this sphere is not a whole sphere. It's half of a sphere. So to get the correct thing, you have to divide this by 2. So really, for that specific sphere, this is going to be 144 pi. So to find the total, you want to add those. 144 pi plus 180 pi. Pi stays. It's like a variable. You're going to have 4, 2, 3, and this is centimeters cubed. So find the volume of both and then put them together just like you would a composite figure. Last, we're going to talk about surface area. Surface area, you find, essentially, you're finding the areas of everything on the outside and adding them together, but there are formulas. So surface area of a cube, you're going to take 6 because there's 6 sides, and the area of a square is s squared. So what you're essentially doing is finding the area of one square, say this one here, and all of them will be the same, so you're multiplying it by 6. Rectangular solid, you're going to have 2 times the length times width. So length times width is the bottom. So what's that saying is the bottom and the top will be the same. So that's where that 2 times come in. You have L times H. L times H, that's going to be the front and the back. And then last, you have 2WH, which is the right and the left. So that's why you do that. So you're finding the area of all those faces and then adding them up. And then for the last one here, 2 pi r squared. 2 pi r squared is the area of a circle. So that's giving you the top and the bottom. And then 2 pi RH, that's going to give you the outside. That's not really a shape. That's going to give you that. So we're going to use 2 of these. So for the first one, surface area is equal to 2, doesn't matter how you do this, length times width, plus 2, length times height, plus 2, width times height. So really what you're doing is you're going to take 2 times 2 times 5. So that's this and this, plus 2 times 2 times 3. So that'd be that there, plus 2 times 3 times 5. That'd be the front and the back. So this would be, the first is going to be bottom top. This is going to be left right. This is going to be front back. So that's how you get all of those different ones, just so you know. So for the first one, you're going to do 4 times 5, which is 20, plus 4 times 3, which is 12, plus 6 times 5, which is 30. 20 and 30 is 50. 50 and 12 is going to be 62. And this is going to be meters squared. Surface area is squared. This is going to be, for this surface area, this is a rectangle. This is a square. So you're going to do 6s squared. Each side is 4. So that's going to be 6 times 4 squared. 6 times 4 squared is 16. 6 times 6 is 36. So this should be 96. And this is going to be feet squared. So there's your surface areas. So we talked about in this chapter volumes. We've talked about composite figure volumes, and we've talked about surface area. So tomorrow we will have homework on this. So if you guys aren't understanding, I do have office hours tomorrow. Make sure you come. I know yours are early. If you need to come at a different time, just email me and I'll make that possible. So if you're struggling, you can always come to office hours. You will work on this homework tomorrow.